continue from today, and alternate day or in this week, every week you will get to notified that the videos lecture. So first I'm going to tell about what is a Spark. A Spark, when we are working with a Spark, so Apache Spark is an open source distributed data framework, data processing framework designed to handle big data efficiently. It allow you to process massive data set across a cluster of computers in parallel. So, means it is an open source distributed data processing framework designed to handle big data efficiently. It allow you to process massive data set across a cluster. This is the definition of Spark. I'm going to elaborate one by one point whatever I have discussed. Means first point, what is big data? What is big data? So big data is nothing but a when we are going to talk about the big data. So big data is nothing but a means refer to the a data set that too large, too fast, and too complexity for traditional data processing tool to capture, store, manage, and analyze efficiently. It is not just about large size, the complexity and speed and diversity of data also make it big on there. So I'm going to talk about the real-time example of big data. So real life example, that nowadays every one person is visiting to the Amazon and Flipkart website, and they are searching the products. If I'm not going to purchase, but I can see that what is the product, what is the price, and what is the review, what is the feature. So in e-commerce website, millions of daily order happening, millions of click stream happening, millions of reviews happening, millions of customer behavior happening on there. So big data help in recommendation engine, fraud detection, and sales forecasting. Whatever data we are capturing, through that they are doing analysis, they are written the process, and through that they are going to uh, recommend the engine and detect the fraud, and what sales forecast, what will be the sales in next year, and what next quarter. All the things they are doing through the big data, whatever data they are storing on there. And right now, the main things means main social media things we are handling, like social media, Instagram, Twitter, and YouTube on there. So you know that these are the two in social media. When we are working with the Instagram or Facebook on there, so every second millions of the records in millions, every milliseconds millions of record in storing in the Facebook data center on there. So billions of photos posting happening, billions of videos posting happening every millisecond, billions of like happening, or these are the millions of comment happening in every millisecond on there. So big data is used to check the trend analysis, ad targeting, and content moderation on there. When we are talking about the transportation, so you already used Ola, Uber. So this real-time ride request means driver real-time drive request and driver GPS data and traffic updates. So real time, how you will get the, suppose if big data is there, so you are simply open the uh, app, and then you will get to know that the you get to know that you are going to search, and then you found that now we are knowing that real time talking about the transportation method like Ola and Uber. So here what will happen, it is real time ride request happening, driver GPS data, and traffic updates happening on there. So what do you mean by real time ride request? Means these are bookings raised by the customer instantly through the app whenever they want a ride. So the system must capture and process the request immediately to the find a nearby driver. So you have opened the Ola and you have entered your location, destination location, and current location. Then you are going to search which mode you are going to travel. Either you want to go with the bike, either you want to go with the auto, either you want to with the four-wheeler. So there are multiple options. The four-wheeler also happening on there. And driver GPS data means this refer to the live geographic location information of driver. Means then after booking you see that the driver is showing nearby 1 kilometer away from your location. It is coming like that, coming from there. So capture using GPS on mobile device. It help the system know where each driver is at any moment for matching the customer request. So another point is traffic updates. So you see that whenever you are driving and you are open the Google map and you have entered the location from the your local system to a different destination system. So you see that the live feeds, there is a live feeds about the road condition, congestion, accident, roadblocks, closure, and gather from maps, sensor, and or the other data provided. They help optimize driver routing and provide accurate estimated time for arrival on there. So these are the come under to the whenever we are talking about the transportation. So the big data belong to the five characteristic, and each characteristic is means first characteristic means volume, another characteristic is velocity, and third is variety, and fourth is veracity, and fifth is value. So when we are going to talk about the volume, so when we are going to talk about the volume, volume is referred to the size of data every day we are consuming. Size of the data every day or every minute we are going to consume on there. So it's referred to the amount of data being generated and stored. So in big data, this is usual to handle TBs data and petabytes data and exabyte data. Traditional system like database, our Oracle, MySQL, MS SQL Server cannot handle such huge size of efficiently. Cannot handle such huge size of efficiently. So it will what will it will do means organization need to distribute storage system like Amazon S3 or ADLS Gen 2 to store these data. It will we cannot rely on the particular traditional system on there. So for example, we know that we are running, I have given example of Facebook also. So Facebook generate over 4 petabytes data, petabytes of new data every day, including photos, videos, and messages on there. So Walmart's and another example with I'm going with the retail company Walmart's that handle 2.5 petabytes of customer transaction data every hour. So every hour. So why does matter? So more data means more opportunity for insight, like pattern analysis, prediction analysis, and recommendation analysis on there. So this is the volume rated. Now I'm going to talk about velocity. Velocity means the speed, or velocity means the speed at which data is created, collected, and processed. In past, data comes slowly, like daily sales report coming, monthly bank statements coming on there. But today, when we are working within now AI in AI world, so but today data is coming every second or every millisecond from different apps, different website, different sensor, and different machines. So velocity refer how fast the data is moving. How fast the data is moving. How fast the data is moving. So why we are focusing on the velocity and why it is important? If data come fast, but you process it slowly, the inside become useless. Example, detecting a fraud. First example, detecting a fraud transaction must happen in 1 second, not after 1 day. Not after 1 day. Detecting a fraud transaction. Suppose any fraud transaction happen with you, so you what you will do? You will go for the after 2 days or 3 days? No, immediately you will check with your bank. Immediately with check your bank on there. So you means that Fraud detection in 1 second means, this means the system must analyze a transaction as soon as it happened and decide if it's suspicious. For example, if someone swap a credit card in another country right after using it locally, the system should block it instantly. This is a real-time and streaming processing. And for this, we need Apache Kafka, Spark structure streaming, and other tools. And if you are going to detect a fraud detection after 1 day, if fraud is detected only when reported or generated the next day, then the fraudulent transaction has already gone through, and this is a batch. We know that this is a batch processing, this is a not real time or streaming processing. So here we are going to use Spark, a batch processing data. So in critical cases like banking and payments, real time detection is essential because delayed detection means money is already lost. Money is already lost. Okay. So then another example. So a self-driving car must process sensor data instantly, must process sensor data instantly, or it will crash, or it will crash. So what do you mean by this? So this is the perfect example of real-time processing. So self-driving car sensor data means the car continuously collect data from the cameras, radar, and GPS. So instance processing required means the data must be processed in millisecond to detect pedestrian and traffic signal. If delay, even a 1 or 2 second delay could cause the car to miss and obstacles and crash on there. So self-driving car depend on the real-time processing, real-time string processing, because safety critical decision must happen immediately. Must happen immediately. Okay. And so business need to process data at the same speed it arrive. Means as soon as we are getting a data, same speed I have to process the data and generate the outcome. That is the thing. So I'm giving the example, another example. So social, suppose I'm, I'm using social media like LinkedIn, Facebook, Instagram, Twitter. So every second, if I'm talking about Twitter, every second Twitter 6,000 tweets happening. Instagram millions of like and comments happening. So platform must process this instant to show trending topics. Trending topics. Suppose you are running Instagram and you have searched, you run continuously one topic video, then you are going to search, open a search option, then you find the same relevant topic videos is showing on there. So like that, so platform, because of that, every time real time processing happening, that's why you are able to see the real trend analytics on there. So when we are working with the Amazon and Flipkart website. So when you click on a product, within a second you see recommendation. Suppose I am going to buy S24 any tablet. So I can see that I have searched for Samsung tablet. Then I can see that Apple recommendation also there, Xiaomi recommendation also there, and another brand's recommendation also there to see that. So it is a real time processing is happening on that. That's why you are able to see that. So data is processed live to improve shopping experience. And if I'm talking, I've already told about the banking fraud detection on there. So if your card is used in two countries at the same time, the system flag it immediately. This is the means there is a fraud detection happen, fraud is going to happen. So they immediately it will block the your fraud on there. So suppose you are using smart devices like your smartwatches on there. So a smartwatch collect your heartbeat every second. If it is abnormal, it will immediately alert you. It will immediately alert you regarding this. So How Spark handle, I'm going to talk about how Spark handle velocity. So Spark streaming and structured streaming are designed for real time data. They process data in macro batches, a small chunk of data every second or millisecond. Okay, that way they are going to handle the data on there. Okay, simple analogy in real time world, what we I am going to example, then you can understand better. Think of data like a water. Think of data like a water. So volume, what is the thing? So the amount of water stored in a big tank, and velocity, the speed of water flowing through the tap is tap. So if water flow too fast and you don't have a bucket ready, it will overflow. Same like a as overflow, and same with the data, like waste. It will waste it, whatever capacity it is contained only, and rest it will overflow. So that is the example. And now I'm going to talk about the variety, the data type, the types of the data. So data come in different form, not just structured tables. So not just a structured table, different from, like different from, like I will show you, different from, like this, uh, structured form and semi-structured form and unstructured form. So in structured form, you know that row and column like data, like SQL database and transaction records. And semi-structured means logs files and JSON file and XML file. When you're talking about the unstructured data, videos, image, audio, and social media post on there. So I'm going to give the example of the variety of data. Means suppose I'm working with the one of the e-commerce website. Here, structured data means order history and product prices. That is structured data. Semi-structured means server log and website click stream. Website click stream. Website click stream means user logged in the particular website, moved on the home page, then search for the product page, then search the product, then add to cart, then check out, then exist. This is the click stream. So it will come like a semi-structured data. And unstructured data means customer review, product images and videos. Customer review and product images and videos means, suppose I have purchased some amount of the some amount, some data, and some uh, goods I have purchased. I found that it's very good. I have to give the review to, and so other one can check my review, and he can buy. Okay, so that is the thing. Why it is matter? The handling multiple data format, handling multiple data format. So help organization gain 360 view of customer and process on there. Customer and process on there. Now I'm going to talk about the veracity. Now I'm going to talk about the veracity. So before going to talk, I will let you know. This is related to the quality and trust of the data. Whatever data we are storing, and what is the data, that is quality. What is that is that will help, or that will not, that will trust, that we can trust on the data or not. So suppose I have a notebook. I work bought a notebook from the shop, and that notebook book I have simply write any real time thing, anything, not any related to my subject learning, not related to my area of working. Only I'm just writing randomly anything. So I will I did as a like a data I have written on there. So it is not a useful for me. I cannot carry that notebook to everywhere. If I have related to topic like PySpark, Python and things, and if I require to memorize all the things, so I have written on there, and I can open and see that this is the topic I have written. I have to revise the things. So that time it would helpful, and I can carry the data. If I have not written important things, it is a worthless. I can throw it away. So that is the same thing here happening here. So refer to the accuracy and consistency and reliability of a data. So big data often has a noise. Big data often has a noise, duplicates and missing values. or inconsistencies on there. So unclean data can lead to wrong insight and bad decision. Wrong insight and bad decision. Bad decision. So, like example, Twitter has millions of tweets daily, but many are spam, fake, or irrelevant. Extracting true sentiment is challenging on there. It's challenging on there. And also, patient data may have error or missing fields, making prediction unreliable. When we are working with the healthcare domain and patient data in healthcare, data may have error or missing fields, making prediction unreliable. So why it is very important, why it is matter, means company must use data cleaning, validation, and governance to improve the veracity or data quality, so insight are trustworthy. Trustworthy. I'm going to talk about another point, value. What do you mean by value? The value means the business impact. So refer to the usefulness of the big data. Whatever data we have stored, how useful is it for our product? Eh, that is the important thing. So big data is meaningless unless it provides business value like insights, savings, revenue, and efficiency. So the goal is to turn raw data into actionable insight. We have to be trust on the particular data, whatever we are getting. So I'm going to tell about example. So Amazon use customer browsing and purchase data to recommend products, which accounts for 35% of its sales. I'm going to the content watching details. So Netflix analyzed viewing patterns to recommend shows, improve customer retention. So have you seen the Netflix and you have searched for something and you find that it will recommendation after completion of the video. You saw some recommendation, or YouTube you see the some recommendation. This is the next episode you have to go visit and you have to watch that things like that. So why it is matter, the true power of big data lies in the exact extracting value of the decision making, customer satisfaction, and innovation. Customer satisfaction and innovation. So this is the related to the 5 ways. Now I'm going to talk about another point, open source. So you know the open source uh, means anyone a software whose source code is freely available for anyone to use, modify, and distribute. To use, modify, and distribute. So in Apache Spark as open source means Spark was originally developed by the UC Berkeley's AMP Labs 2009. The open source is 2010 under the Apache 2.0 license, and now maintained by the Apache Software Foundation. Non-profit that ensure project stay open, community governed, and vendor neutrals on there. And there are too many other companies also uh, doing research and contributing to Spark, but nobody own it. Own it. Nobody own it. Nobody claiming that it is my product as things, but that's why it is a open source. Now I'm going to talk about distributed data processing framework. Distributed data processing framework, I'm going to divide these three into three parts. First is distributed, second is data processing, and third is framework. So distributed means nothing but a work is divided across multiple computers, nodes, instead of one machine. So whatever work you are doing, it will whatever data you are giving. Suppose you have given 10 GB of data, so it will internally it will create a partition and divide into the different executed for processing. Like that, it is happening here. So data processing means operation like filter, aggregation, join, and analyze data. Suppose anyone come to me and ask, I have a 1 GB CSV data that contain the data of all 50-50 cricket World Cup. I have a few questions I have a few question. I have to apply. Want to get the answer. Like player name who played most of the match. Player or who or, and player name who of the World Cup who have played most World Cup edition. Then I will. What will I do? I will apply the. I will first. I will read the data. First, I will create a Spark session. Then we read the data. And then we'll create a data frame. On top of the data frame, I will apply the filter. Then I will apply the join if any required. Then I will apply the aggregation if required. Okay. Then I will give the predict the answer. So that is the thing. Now another part is framework. So framework is nothing but a structured platform that provides APIs, libraries, and tool to make it easier for the developer to build big data applications on there. Big data applications on there. Applications on there. So in one word, so distributed data processing framework means a system that let you process very large data set by splitting the work across multiple machine automatically. This is the main definition of the distributed data processing framework. Then why distribution is needed? Why distribution is needed? Suppose I have a 1 GB of data and 1 GB of data. I want to process the things, and if I'm working with a single computer, I'm talking about my laptop only, that contains 16 GB of RAM. So we know that Spark will work on the memory only, in memory computation part. So if I have only 16 GB RAM and I have a one core only. So whether it is able, I had two cores only. So whether it is possible to possible to it will manage the 1 GB CSV data? No. So means in a single computer, memory and CPU are limited. Large data set like terabyte or GB, a click stream data cannot fit on this. And if by chance, luck by chance, it would fit on there, so it will take a more time for processing. More time for processing. When we are when we are working with a distributed system, data is partitioned into a smaller chunk. These chunks are processed in parallel across multiple machines, and after processing, what then result will get, and it will result, whatever result we are getting, it will combine back and efficiently on there. So this is the when we are working with a distributed system. So as Spark as a distributed data processing framework, how I will let you know. Means Spark automatically split your data into partition, assign each partition to the worker node or executor under executor in the cluster, run the task in parallel on a different node, handle failures, and after it's done, combine result are given final output on this. You don't have to manually worry about distributing the data. Spark does it under the hood. Spark does is the under the hood on there. So suppose I'm giving the example of that. Imagine you have a 10,000 exam paper. Suppose I am a principal of the school and I have a 10,000 exam paper to be checked. But I have only one teacher to check the all. It If I'm going with the one teacher, it will take a weeks. If I have a 50 teacher, I can divide the 200 papers to at the same time to every teacher, 50 teacher. Then the work will done in a day. So in the same way, Spark is the coordinator. Means here coordinator means principal. Assigning paper, that is a partition to each teacher means executor, and coordinator is nothing but a principal is nothing but a driver here in Spark. Means Spark is the principal means driver. Assign paper means partition to each teacher. Teacher is nothing but executor, and finally combine the scores on there. Finally combine the scores on there. So this is the today's class. Today's class lecture.